Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Fadli Abdul Kahar with my friends Fatil Akramin, Muhammad Aziz Nazmi, Nur Fariruddin, and Nur Fakhruddin. Today, we would like to present a way of solving a problem from a given assignment. Firstly, what are matrices? A matrix is a reticular array of variable or constant in a horizontal row and vertical column, usually enclosed in bracket. Each value in a matrix is called an element. The dimensions of matrix are the size of the matrix measured in row and columns. A row matrix is a matrix with only one row. Next, a column matrix is a matrix with only column row. Moreover, a square matrix is a matrix with the same number of rows as columns. Furthermore, a zero matrix is a matrix in which every element is zero. Lastly, equal matrices have the same dimension and each element is equal. Next is there are several uses application of matrices. Firstly, is they are used for plotting graphs, statistics, and also to do scientific studies and research in almost different fields. Matrices can also be used to represent real-world data like population of people, infant-mortality rate, and so on. They are the best representation methods for plotting survey. Application of matrices in engineering. Transformation matrices are commonly used in computer graphics and image processing. Matrices are used in computer-generated image that we have a reflection and distortion effect, such as height passing through dripping water. This is how application of matrices in engineering is used. Lastly is the idea of application of matrices in business is that you have a multiple inputs and you have a multiple outputs and you are trying to predictively model change independent variable by examining the impact of numerous independent variables that do provide explanation. The coefficient factors of the variable used lend themselves to a matrix form. This is how application of matrices in business is used.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And it's my turn. My name is Fatul Akramin Azman and my matrix number is DD12012. And now we would like to discuss about the problem 1A. Alright. As the problem 1A state that we must times the P times Q, which is P is a 3 times 4 matrix and Q is a 4 times 5 matrix. 3 times 4 matrix is actually the column and row is actually 3 times 4. Otherwise, Q is a 4 times 5 matrix, which is its column and row is 4 times 5, as we can see here. Alright. So, how do we do the calculation step? As we can see below here, it is the actual calculation step that we need to follow to get the actual number, which is as I calculate, I get the answer of 116, 90, 92, 96, 112, 76, 84, 88, and 104, 108, 114, 116, 92, 88, 130, and for the last one is 76, which is this is the real actual calculation step that we need to follow to get the actual answer. The answer that I jot down in my paper, I have pinned it in the worksheet. That's all from me. We move to the other presentators. That's all. Thank you.
Thank you, Fatul Akramin, for the 1A question, for the explanation for the 1A question. So I will proceed to problem 1B. First of all, my name is Muhammad Aziz Nazmi bin Afandi. I am from class Diagnostic 2B, and today I will show to you my solutions to get the answer for question 1B. So we will proceed. The question asks us to add matrix P and R and multiplied by Q. So as you can see, matrix P is a 3 by 4 matrix. Same goes to matrix R, which is 3 by 4. So we are going to do the first thing in here, which is the addition P and R. Before we doing addition for matrices, we must make sure the matrix must be the same size, and if not, we cannot add those matrix. So I am going to show to you how I add in this question for matrix P and R. So I am going to start with the number 2, which is the first row, first column. Then I will add it to number 0, which is also the first row and the first column for the R matrix. So we will add these two and get the answer here. First row and first column also here. So we are matching this. For example, this number 4, first row second column will be also added into will be also add to number 2, which is also the first row second column number, and the answer will be also at the first row second column. And same goes to the other number. As an example, I take this number 6 at the second row second column. Then I will add it to matrix R number, which is 3, second row second column also. 6 plus 3, then the answer will be 9, and then we place the number at also the second row and second column. It's quite easy. The addition is not a problem. And then after we got the answer for the P and R, the question asks us to multiply the matrix P plus R with Q. So as you can see here, Q is a 4 by 5 matrix. And how can we know that this? How can we know what matrix can multiply by what matrix? Not all matrix can be multiplied. So what I learned is, for example, P plus R is a 3 by 4 matrix. So I must write this down first, and then what matrix is multiplied by this matrix. So in this case, is Q. So it is 4 by 5 matrix. So after this, we are going to see the number at the end of the matrix 4, and for the matrix Q, the front number 4. So if these two are the same number, so absolutely you can just multiply it, and then the answer will be the first number of matrix P and R, and the last number for the matrix Q. So it is 3 and 5. So the answer will be in 3 by 5 matrix. That is what I learned. And then I will show you how we will multiply this matrix. So first of all, I am going to take this first row, first row number, and I will multiply it with the first column in Q. So I will take this. So 2 will be multiplied by 1, and then 6 will be multiplied by 9, and then 9 will be multiplied by 1, and then 9 and then 9 will be multiplied by 9. So this is for our answer. As you can see this table, this is for our answer. 3 row and 5 column matrix. So after we take the first row and the first column, after we multiply it, the answer will be in row 1 and column 1. And then I will take the second row, multiply it by the first column of Q. So we get row 2. We can get the number for the answer of that matrix here. I think you can see clearly. What I learned is we can multiply this matrix by using the L concept. Yes. Why L? Because as you can see, this. Wait, sorry. As you can see, this. I will. Yes. And take this row, and then this column. So is an L. So and so on lah for the next number. But I will give you my last example. So for column for column 269 for column. Okay, tak apa. And lastly, after we multiply and also adding the this number in this box, then we can get the answer as simple as that. So that's all from me for problem 1B. And thank you.
Hi, Assalamualaikum. My name is Nofakuddin bin Saad from class Diagnostic 2B. Now, I will show you how to solve problem number 2. This is question problem number 2. First step is determinant. We need to find determinant first. Throughout determinant of 3 multiply 3 matrix, multiply A by the determinant of the 2 multiply 2 that is not row or column. Cross out the row and column of your first element. Look at the row or column, you select the circle the first element. You should be left with 4 number, and the last you can get the answer is 1. After that, we need to find the minor. The minor is the value of the determinant of the matrix that result from crossing out the row and column of the element. For the element 2 in matrix A, since this element is in the first row and first column, we cross out the first row and column of A to leave the 2 multiply 2 matrix. And the answer is first row 3, 4 and negative 1, second row 1, 2 and 0, and third row negative 1, and 2. After that, we need to find the cofactor. Determine the sign of your answer. You multiply your answer either by positive or negative to get the cofactor of your chosen element, which you use depend on the element was placed in the 3 multiply 3 matrix, and the answer is first row 3, negative 4, negative 1, second row negative 1, 2 and 0, and third row negative 1, 1 and 2. After that, step 4 is find the adjoint. Now, transpose all elements of the previous matrix. In other words, swap their position. And the answer is first row 3, -1, -1, second row -4, 2 and 1, and third row -1, 0 and 1. And step 5 is find the inverse. And the answer is first row 3, -1, -1, second row -4, 2 and 1, and third row -1, 0 and 1. Finally, we will get the answer is first row 1, 0 and 0, the second row 0, 1 and 0, and third row 0, 0 and 1. That's all. Thank you.
Hi, my name is Nur Fariduddin bin Saad. I will solve the problem 3. The question given for problem 3 is give one example of words problem in real life in engineering, business or economy to show application of solving system of linear equation with 3 variables by using Cramer rule. Okay, based on the problem 3, this is the required question from problem 3. Analyze the circuit below and determine the all unknown parameters in the circuit using mesh analysis method. Define the mesh current by labeling them. This includes showing the polarity of each mesh current. Solve the matrix equation using Cramer rule. Write your final answer in below. Okay. This is the diagram based on the question I create. So, in order to solve this problem, the circuit has been divided into 3 parts: I1, I2, and I3. To complete the circuit I1, first we have to know the direction of electric to us the works. In mesh 1, in mesh I1, lastly we can get 430 I1 minus 330 I2 equal 3. So this is answer from circuit I1. After that, we have to finish circuit I2. Same as circuit I1, we have to know the direction of electric. So the problem will be solved. In mesh I1, we will get answer negative 330 I1 plus 630 I2 minus 100 I3 equals 0. Lastly, we have to finish circuit I3. Same as other circuit, we have to know the direction of electric. So the problem will be solved. The answer for mesh I3 is negative 100 I2 plus 430 I3 equals 0. Okay. Fahim turns to explain.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Fahmi Abdul Kahar. I will be the last presenter for our group, which is I will continue equation 3 but solving the equation. Therefore, it is already written in the question where we need to solve the problem using Cramer's rule. So in Cramer's rule, after we get the equation, we need to change it to matrix form, which is the first one should be a matrix 3 by 3, matrix unknown, and followed by a matrix answer. As you can see at the right corner of the slide, there is a formula to get the determinant. The way to get the determinant is we use the first row, A11, A12, and A13, multiplied by their minor. So how do we find their minor? For example, in this slide, A11 minor, we just need to choose the first row and also a column. So the leftover matrix is A22, A23, A32, and A33. This matrix, we call it as a matrix minor. So after that, to define the minor of matrix A11, we need to do a cross multiply within A22 and A33 minus A23 multiplied with A32. So this step will be repeated again on A12 and A13. So back into the equation 3, we have changed the equation to form a matrix to a matrix 3 by 3, matrix unknown, and matrix answer. Based on value matrix 3 by 3, to find origin determinant, 430 multiplied with 230,900 minus with negative 330 multiplied with negative 141,900 plus with 0 multiplied with 33,000. Determinant's origins is 65,360,000, or in a simple form is 65.36 micro. The next step is to find determinant of each mesh current. To find determinant of each mesh current, we need to change the matrix answer with a matrix 3 by 3. For example, to find determinant mesh current 1, we will change the matrix answer with a column 1 of matrix 3 by 3. Then we will apply formula determinant on this matrix. So for the determinant of mesh current 2, we're gonna do it again we're gonna do same as the determinant of mesh current 1. We're gonna change the column to matrix 3 by 3 with a matrix answer. So the answer will be 425.7 milli. So it will be the same again as the determinant of mesh current 3, which is we will change the matrix answer with the matrix column 3 by 3. So the determinant of mesh current 3 is 99 milli. Now is the last part. We need to find the value of current 1, 2, and 3. To find the value of current 1, we will apply formula determinant of mesh current 1 over determinant origin. So it will be 782.7 milli over 65.36 micro. And the last final answer for value current 1 is 11.98 milliampere. So for the current 2 is a 425.7 milli over 65.36 micro. The final answer of current 2 is a 6.51 milliampere. And the last is current 3, 99 milli over 65.36 micro. And final answer for current 3 is 1.52 milliampere. That's it from me. Thank you.